Now we're going to be taking a look at the challenge problem, split list into two equal groups. The problem states that, given a list of integers, create a recursive function to determine whether the integers can be divided into two groups such that the sum of the two groups are the same. Every integer in the list must be in one group or another, but not both. And we're told as a hint to create a recursive helper function. So if we take a look at the function description, we can see that split list has a parameter lst, which is a list of integers. And we can see for the sample input that we can in fact divide 5, 2, and 3 into two groups such that the sum of the groups are equal, because one group can have 5 and the other group can have 2 and 3. And for the next sample case, we can see for 5, 2, and 2 that the output is false because we cannot group up the elements so that the groups are going to sum up to the same value. Before we even take a look at any code and write any code, let's think about what our algorithmic approach to solving this problem might be. Let's say for the list 5, 2, and 3, how are we going to group these so that group 1 and group 2 sum up to the same value? Well, what we can do is we can try adding 5 to the first group, then we can add 2 to the first group, and then we can add 3 to the first group, and we've exhausted all of the numbers in the list. And then we check, is the sum of group 1 equal to the sum of group 2? The sum of group 1 is 10 and the sum of group 2 is 0. So we know that group 1 doesn't equal group 2, the sum. But we know that this isn't the only way we can group 1 and group 2, or group the elements into group 1 and group 2. We can undo our decision to put 3 in group 1 and put it in group 2 instead. Now we still run out of numbers to use in our list, so we're going to need to check, is the sum of group 1 equal to the sum of group 2? Well, 7 isn't equal to 3, so we know that this isn't going to work, but that doesn't mean that all hope is lost. What we can do now is we can choose to put 2 inside group 2 instead. But where do we put group 3? Well, let's just put, where do we put the number 3? We can put 3 into group 1, and we're going to check, is group 1 equal to group 2, the sum? Well, 8 isn't equal to 2. But again, not all hope is lost because we haven't tried every single possibility yet. We can undo the decision to put 3 in here and put it in group 2 instead. Now we've still exhausted all of the integers in the list, so we're going to check, is the sum of group 1 equal to the sum of group 2? Well, 5 is equal to 2 plus 3, so we know that yes, in fact, we can split the numbers in this list such that we can group elements in the list such that the two groups are going to add up to the same value. Now, how exactly are we going to do this in code? Well, we're going to want to have some sort of notion of a group 1 sum and a group 2 sum. Now we're going to do this by creating a recursive helper function. So right here, we're going to call our recursive function, our helper function, and I'm just going to call it helper. And in helper, we're going to pass our list, lst, and we're going to pass in two numbers which represent the current sum of group 1 and group 2. Now, if we're just passing in lst as it is right now, we know that lst is going to contain all of the integers in the list. So we know that the sum of group 1 is going to be 0, and the sum of group 2 is also going to be 0, because we haven't chosen or elected to put any of the integers in lst into either group. So we're going to do 0 and 0. Now we're going to need to define a helper function, and we're going to say that the first parameter is lst, which is our list. And then what we can do is say group 1 sum and group 2 sum. Now we know that the first time we call this helper function, group 1 sum and group 2 sum are going to be 0. Well, what do we know here? Let's say that we were given a list of integers that was empty. Well, could we divide all the integers into that list into two groups such that the sum of the two groups are the same? Well, yeah, that would just be a trivial solution because there are no integers to consider. So what we can do is we can say, if our list is actually just empty, we can return whether group 1 sum is equal to group 2 sum. And in this case, it's gonna evaluate to true because 0 is equal to 0 if we were to have been given the empty list to start out with, and everything all is well. So this is going to be our base case. Now now that we've handled our base case, let's think about it a little bit more in terms of what is like the more complicated case. Well, what we can do is if we go back to that if we go back here, what do we first consider when we had let's go back all the way till right here. We first elected to put 5 in group 1, and then we just kind of kept trying until things worked out. But what if things never ended up working out? Well, we would have then undid the decision to put 5 here and put 5 in group 2 instead. So we know that whenever we choose to put a number in a group, we can either put it in group 1 or group 2, but not both. Because as I said in the problem description, every integer in the list must be in one list or another, but not both. So what we can do is we can return helper lst1 starting from 1, which basically the reason for this is at this point when we call our helper function, we do want to either put the first element in the list in group 1 sum or group 2 sum. So once we call our recursive helper function, once we call helper again, we don't want to, we're done considering the first element in that list. But let's say we chose to put, in the example that we had for 5, 2, and 3, let's say we chose to put 5 in group 1. Well, then we can denote that by doing group 1 sum plus lst0, so the first element in the list. And because we didn't add it to group 2 sum is going to be left as is. But this is just one possibility. We could have elected to put lst0, which is the first element in the list, into group 2 sum, right? So we're going to do or helper lst1 again, because we know that when we call our recursive helper function again, we don't want to, or rather, we've already considered the first element. We put it in either group 1 sum or group 2 sum. So we're going to do group 1 sum this time, but just group 1 sum, because now we want to add it to group 2 sum. And believe it or not, this is actually going to work. So if we run it, it's gonna output true, which is what we expect. And if we run all the test cases, it's going to pass all the test cases. Now you might be wondering, why exactly does this work? Well, this algorithmic approach is something called recursive backtracking, which is an algorithmic technique for solving problems recursively by trying to build a solution incrementally, one piece at a time, and removing solutions that don't work, or they don't satisfy a constraint of our problem, which in this case our constraint is whether group 1 sum is equal to group 2 sum. Now it might be a little bit confusing about why this exactly works still, so I've put the call stack and I've typed this up so that it corresponds to what's going on the right. So the first time, let's say we were to again use our example 5, 2, 3, and 0, 0. So LST is 5, the list 5, 2, and 3, and we call helper and we pass in 0 and 0. So this is the first call to our recursive helper function, and let's look at our code. If length of LST is equal to 0, well, we know that 5, 2, and 3 right here, this is LST. Is LST's length 0? Well, it's not. So we're going to go into the else statement and we're going to do return helper LST starting from the first index, or the first index 1. So we're going to do return helper, and then we're going to slice off the first element in the list. So it's going to be a helper 2, 3. Group 1 sum we know is 0 because that corresponds right here. And we're going to add the first element in the list, so 0 plus 5, and then comma 0. Or helper, again, we're going to choose to keep the rest of the list, but we're going to add it to group 2 sum instead. So this helper 2, 3, 0 plus 5, 0 corresponds to this call right here. And again, we know that the length of 2, 3 isn't 0, so we're going to go into the else statement and we're going to return this. Helper 3, 5 plus 2, 0, which corresponds to here. And again, this corresponds to this. So eventually, when we decided, like I originally showed in right here, when we chose to do 5, add 2, add 3, that's exactly what's going on in the code right here. We've decided to add all of the elements to group 1, so we've gotten 10, and we say, hey, is 10 equal to 0? Well, no, it's not, so this is going to return false. And so this result of false is going to go back up to here basically if you visualize it, and we're going to return false, or now we know this is a Boolean or statement, so not all hope is lost. This statement right here could evaluate this statement right here could evaluate to true. So we need to check what happens if we do helper and we pass into empty list 7 and 3. Well, that corresponds to this. Now we check, is 7 equal to 3? Well, it's not, so it's going to return to us false. So this statement right here, again, return helper 10, 0 or helper 7, 3 is going to return false or false, which unfortunately is going to return to us false. Now again, not all hope is lost because that is just corresponding to this. So we know we can still check helper 3, 5, and 0 plus 2. So this call is going to correspond to this right here, this segment of code. Now we're going to check, is the length of this list 0? Well, it's not, so we're going to go into the else statement like you can see on the right screen, and it's going to go return helper, the empty list 5 plus 3 and 2, and then we go here. We're going to say return 8 equals to 2, which is false. So this is going to return false back to here, but we still have to check this. Helper, the empty list 5 and 2 plus 3, which goes right here. We have the empty list, so we actually do go into the base case and we check, is the length of our list 0? Well, it is, so we're going to return whether group 1 sum is equal to group 2 sum. 5 is equal to 5, so we're going to return true. So this statement is actually going to return to us false or true, which we know is going to be true. Well, that's good because that means that this statement right here actually evaluated to true. So we're going to return to us right here, all the way back here, it's going to be true. And so although this was false, and this is getting a little messy, although this statement right here was false, this statement right here was true. So this statement effectively, helper 2350 is actually going to return to us true. And this result is going to go back up to here, which is, remember, if we remember, this is our original call. Return helper 2350, this is going to evaluate to true. Now true or whatever this result is, helper 2300 plus 5, is actually going to evaluate to true as well, but that's not actually important because our Boolean OR only cares that one of them is true. And so because we know that the first part of the OR statement evaluates to true, we know that the call to helper 523 this evaluates to true. And you know, that actually that matches what we would expect, right? Because we know just from looking at it that 5, we can group 5, 2, and 3 into 2 groups, such that the 2 groups sum up to the correct number. And in case all these arrows were kind of confusing, I've also listed a call stack on the right, which is just to show you what exactly is going to happen, like what code is going to be executed at a time. So the first time we call split list and we pass in 5, 2, 3 right here as LST, we're going to call our helper, which is going to do helper 5, 2, 3, 0, and 0. Then helper 5, 2, 3, 0, 0 is going to return helper 2, 3, 0 plus 5, 0 right here, and that corresponds to this. And then this helper 3, 7, 0 corresponds to this. So basically, this is the order, this arrow is the order of basically what code is being executed at a given time. So this is going to be called first, then this, then this, then this, then this, then that, and then that, and then that. And then eventually we know that this is going to return to us true. And what call on the stack actually ended up calling helper the empty list 5 and 5? Well, we know that was helper 3, 5, and 2 because of this arrow. Helper 3, 5, 2. So this helper 3, 5, 2 is going to value to true. Well, what called helper 3, 5, 2? That was helper 2, 3, 5, 0. So this. And helper 2, 3, 5, 0 was called by this. So ultimately, we're gonna return true, and that is actually what we wanted. So now that we're happy with our solution, we can submit code and move on to the next problem.